If you've ever been to a veterinary clinic with your pet, you've probably noticed the high costs of getting your pet diagnosed with something. These are the costs of diagnostics, and they're often higher if diagnostics for your pet involves diagnostic imaging, which is a practice where things like CT scans, x-rays, or ultrasounds are taken of your pet and then interpreted by a veterinarian to provide a diagnosis. The issue with this is that it costs more because you're factoring in the cost of having an expert, sometimes even a veterinarian who is specialized in interpreting these images, looking at the image and coming up with a diagnosis. In human medicine, AI, or artificial intelligence, is being explored as a solution to make diagnosis cheaper. AI, or artificial intelligence, is able to classify images. So an image of an ultrasound could be classified to tell if there is a tumor or not in the image. This is extremely useful and is currently being researched for human medicine, but I believe that it could be easily transferred for veterinary medicine. Because of this, I decided to learn how to implement AI models and code them. The project I chose to start with is the classification of the NIH chest x-rays dataset, containing 5,000 images with 15 different classifications of different cardiac or chest conditions, or of no findings. To make this model, I used Google Colab, which is a free resource on Google Drive for anyone who wants to write code, and I coded my model with Python. I also used TensorFlow as my library. My first step in creating this model was to do the necessary imports of the modules that I would be using. Next, I set up the labels from the CSV file, which had the different classifications, and turned them into numbers so that the computer could better comprehend them. Next, I changed the labels and images to NumPy arrays so that they could be fed into a machine learning model. And then I split the test and training data to make sure that the model could be tested on images after being trained and to prevent overfitting. Next, I set up image data augmentation using the image data generator function on TensorFlow and performed various functions such as horizontal flips and rotations to ensure that the training data was varied and to prevent overfitting. The last few steps before compiling the model were to set up Inception, which was the model I used, global average pooling 2D to normalize the inputs, and dense to create connected layers. I then compiled the model and ran it, and got a 53% accuracy for 15 different classes. I think that the reason the accuracy was as low as it was is because of the limited data. There were only 5,000 images for 15 different classifications, and many of the classifications were rarer than the others, which means that there wasn't a lot of data for the machine to learn from. In my next project, where I will be looking at identifying metastasis in images of cell slides, I will be using a much bigger dataset with thousands of images for only 2 classifications. If you'd like to stay updated on my work, please subscribe on YouTube, LinkedIn, Medium, and Twitter to receive any updates. Thank you.